The purpose of this video is to go over some of the basic vocabulary that we will use in chemistry throughout the year, provide you with some examples of some of these concepts, and hopefully enhance your understanding of these terms, many of which we simply do not have a lot of class time to discuss at length. These are vocab words that we will use in class, but we may not have a lot of time to go back and just introduce them to you in a format that provides definitions. We already talked about how all of the things around us are chemicals or made of chemicals, and when we're talking about all of that stuff, we're really talking about matter. Matter is a word we use in chemistry, and its formal definition is anything that has mass and takes up space, which means occupies volume. Just about everything around us is matter. Mass is a measurement of how much matter an object has. We like to think about that as weight, but it's different than weight, and we'll talk in class about the difference between mass and weight. Volume is a measure of how much space matter takes up. Chemists study matter. They study the composition of matter, how it's made, what it's like, and those properties of matter, the characteristics that we use to identify matter, and the changes that matter undergoes. Whenever matter undergoes a change, energy is always involved somehow. Remember, energy is not matter. It isn't made of chemicals. We talked about that and how light and heat and electricity are not chemicals. Those are energy forms. All energy changes are either exothermic or endothermic. So when chemists are studying the changes that matter undergoes, they're often looking at whether there's an exothermic energy change or an endothermic energy change associated with that change in matter. Exothermic is when energy is released, so energy is coming out of the system. When we leave a building, we look for the exit sign. That tells us that we're going to go out. We can remember this term by thinking about that exit sign when we look at the word exothermic and know that energy is going out of that system. It's exiting that system. An endothermic change is a change in which energy is absorbed into the system. Now that first syllable of this word, endothermic, it's a 4-syllable word. That first syllable is in, and even though it's spelled differently, it sounds like the word in. So we want to remember that an endothermic change is one in which the energy is going into the system. If we touch a beaker that has an exothermic change happening in it, that beaker is going to feel hot to the touch because that energy is coming out of the chemicals in that beaker, and so we're going to feel that heat coming off of that change if we put our hands too close to that beaker. In an endothermic change, energy is absorbed. So if there's an endothermic change happening in a beaker and we touch the side of the beaker, it will feel cold to the touch because it's actually pulling energy in, and that energy coming away from our fingers will give us that sensation of something being cold. When we look at the changes that matter undergoes, those changes are either physical changes or those are chemical changes. In a physical change, the identity and the properties, which is another word for characteristics, of the substance remain the same. I can take a piece of paper and I can wad it up, I can rip it, I could put it in water and make a wet paper ball out of it, and it's still paper, and the water I added is still water. Haven't changed the identity of that substance. If I take that same piece of paper, though, and burn it, that paper isn't paper anymore. It's undergoing a chemical change because the identity of that piece of paper as paper is going to change. It no longer is paper. In a chemical change, the actual identity of the substance and the properties or characteristics change, but in a physical change, the identity remains the same. Examples of physical changes include cutting things into smaller pieces, dissolving sugar into water is making a mixture. There's still sugar there, there's still water there. The identity of those substances have not changed. When ice melts, it was frozen water. It melts, it's liquid water. Changes of state, which would be melting and freezing and boiling and condensation, those are physical changes. Chemical changes include burning. When we take dough and we bake it in the oven, we're actually adding energy to that. That's endothermic. We're putting energy in order to make a chemical change occur. And when the dough comes back out of the oven, it's not mushy anymore, it's not gooey anymore. It has different properties. The bread is a little bit spongy, it's drier and softer. It has those air pockets in it that weren't there before. Those are chemical changes that make the properties different. All biological processes like the growing of grass, your hair growing, your skin replenishing the cells when it replaces the skin over a cut and makes a scar tissue there, those are biological processes, and those involve many complicated chemical changes. If you get a stomach ache because of something that you ate, those are chemical changes contributing to that stomach ache or headache. If you take medication to relieve those symptoms, those are chemical changes that are occurring in your body to make those symptoms go away. Silver tarnishing or iron rusting, those are chemical changes because the actual nature of the substance is changing. It's becoming a different type of matter. If an apple is left exposed to the oxygen in the air, it'll begin to rot. That is also a good example of a chemical change. When chemists describe substances, they look at the properties or the characteristics of those substances, and those properties are also categorized as either physical properties or chemical properties. Physical properties do not involve a chemical change, and chemical properties are descriptions of substances that involve a chemical change. Page 15 and 18 in your text are great references to learn more about these two concepts. Examples of physical properties, you're already familiar with many of them. Color is the most common. We identify most things based on the color. You would know the difference between a lemon or a lime based on the color of the peel there. You would know the difference between an apple and a banana by that color, and of course the shape of the fruit as well. Odor, the way something smells, is a physical property. Density, we're going to talk a lot about density later. Texture, some things have a very rough texture. Some substances have a smooth texture. Some substances are sticky and some aren't. Boiling point is the temperature at which something will boil. Melting point is the temperature at which something will melt. Water is easy to melt, but iron nails not so easy to melt. You'd have to add a lot more energy for that. Taste is a physical property, but we don't use that in the laboratory. We don't taste things in the lab. That could be dangerous. We wouldn't do that. Chemical properties are a whole category of properties that you're less familiar with. You might be familiar with whether or not something would burn. You would know that a brick thrown into a fire probably will not burn, but a piece of cloth would. The flammability of a substance is an example of the chemical property of that substance. Again, chemical properties always involve some kind of a chemical change, and those you don't know a lot about, and that's what you spend your time in chemistry learning about these chemical properties. Here are some questions for you. Ice melting, is this change exothermic or endothermic? Well, if the energy is coming out of the ice melting, it's exothermic. If energy is going into the ice melting, it's endothermic. Well, let's see, if I needed to melt a big piece of ice quickly, I might put it in a pan and put it on the stove and turn on the stove, which means I would be adding heat into the ice, so it would be an endothermic change. Is this physical or a chemical change? Well, it's H2O water when it's frozen, and it's still H2O water when it melted, so that's a physical change. A candle burning, is that exothermic or endothermic? If you imagine putting your fingers over top of that flame, I think you would identify that as a, yes, exothermic change. Heat is coming out of that. It's exiting the system. A candle burning is a chemical change. In time, that candle would look as though it would disappear, and it didn't actually disappear, but those molecules in that candle are being converted to other substances, primarily carbon dioxide and water, as they burn. Many students point out that the top of the candle melts, and melting is a physical change, and that is true. In order for a candle to burn properly, the top layer of that wax does melt, and that's a physical change. And that melted wax is the part that's actually burning at any given time, and that burning of the wax is a chemical change. Baking bread, is that exothermic or endothermic? You're right, that's an endothermic change. The bread wouldn't bake if we didn't add heat to it. Baking bread, it is indeed a chemical change. When silver tarnishes, the actual atoms of the silver react with the oxygen in the air. You see that color change? That dark blackish gray material that is the tarnish is the silver oxide. That is a chemical change because the silver is being converted to something that's different, silver oxide. Tarnishing silver is a chemical change. If we dissolve sugar into water, both the sugar and the water remain present in that mixture. Neither of them have changed their properties or identity. It is a physical change. The evaporation of water. Keep in mind, the water on the pavement is water, H2O. It's a chemical we're all familiar with. And the steam is coming off of that pavement that is still made up of H2O water molecules. That's a physical change. Let's see, is evaporation exothermic or endothermic? Well, the sun is providing energy, which is going into the water on the pavement, so that is an endothermic change. What are some other properties of substance that chemists might use to describe the substances that they're investigating? There are many physical properties. Here are a few. Conductivity. Whether or not something conducts electricity, that's a property of that substance. Plastic doesn't conduct electricity, but metal wire does. That's a physical property of those substances. We're all familiar with odor. We can recognize odors, some pleasant, some not. Some substances will dissolve in water, but some substances won't. Solubility is a physical property. Different substances boil at different temperatures and also melt at different temperatures. Those are properties of those substances. Viscosity is an interesting property. This setup is a viscosity tester, and they have a substance in a container, and they're timing how long it takes for that substance to drip through. Viscosity is a measure of a substance's resistance to flow. Water would flow through that container quite quickly. Water has a low viscosity, but if you substituted that and put syrup or honey in that container, those substances would take longer to move through, to drip through the container. Honey or syrup have higher viscosities than water. They have a higher resistance to flow. Viscosity means resistance to flow. It's a physical property. The hardness scale is a scale that's often used in the field of geology. Different substances that we get from the earth are harder or softer based on their chemical makeup and composition. A number 10 on the hardness scale is attributed to a diamond. It's the hardest substance, and a piece of diamond could scratch any of these other substances that have lower hardness. Elasticity, whether or not something will stretch, is another physical property. There's so many, and we'll be learning so many of them throughout the year. Hopefully this has helped with some of these terms. When you come to class, you should be able to answer questions similar to these examples and be familiar with these terms when you hear them. See you soon.